our lesson today, solving equations, first degree equation and the second degree equation together. Set of zeros, domain of the fractional function. Our first example, y equals x minus 1. The second degree equation, y power of 2 plus x equals 7. So we put y equals x minus 1 in the second equation. We get x minus 1 power of 2 plus x minus 7 equals 0. We expand this perfect square as x power 2 plus 1 minus 2x plus x minus 7 equals 0. We add the like terms. We get x power 2 minus x minus 6 equals 0. We factorize this expression. We get x minus 3 by x plus 2 equals 0. So we have x equals 3 or x equals negative 2. We get the value of y equals 2 and y equals negative 3. So we have the solution set 3, 2 and negative 2, negative 3. The second example, x plus y equals 7. The second degree equation, xy equals 12. We put y equals 7 minus x in the second degree equation. We get x bracket 7 minus x equals 12. We multiply x by this bracket. We get 7x minus x power 2 minus 12 equals 0. We rearrange this equation. We get negative x power 2 plus 7x minus 12 equals 0. And factorize this expression. We get x minus 3 by x minus 4 equals 0. So we have x equals 3 or x equals 4. We get the value of y equals 4 and y equals 3. So we have the solution set 3, 4 and 4, 3. The length of rectangle is 3 cm more than its width, and its area is 28 cm squared. Find its perimeter. We have two equations. The first, x minus y equals 3. The second degree equation, xy equals 28. We put x equals y plus 3 in the second degree equation. We get y bracket y plus 3 minus 28 equals 0. So we multiply y by this bracket. We get y power of 2 plus 3y minus 28 equals 0. We factorize this expression. We get y plus 7 by y minus 4 equals 0. So we have y equals negative 7. This is refused because no length in negative. So finally we have y equals 4 and we get x equals 7. So the perimeter of rectangle, length plus width by 2, 7 plus 4 by 2, it will be 22 centimeters. Right angle triangle of hypotenuse length 13 centimeters and its perimeter is 30 centimeters. Find the length of the other two sides. First, we draw right angle triangles and we put the two sides of the right angle x, y, and the hypotenuse is 13 centimeters. The first equation, x plus y plus 13 equals 30. So we get x plus y equals 17. The second degree equation is the Pythagoras theorem, which is x power 2 plus y power 2 equals 13 power 2. We put y equals 17 minus x in the second degree equation. We get x power 2 plus bracket 17 minus x power of 2 equals 169. We expand the perfect square. We get x power 2 plus 289 plus x power 2 minus 34x equals 169. We add the like terms together. We get 2x power 2 minus 34x plus 120 equals 0. We factorize this expression, we get x minus 12 by x minus 5 equals 0. So we have x equals 12 or x equals 5. Find the value of y equals 5 or y equals 12. So the two sides of the right angle triangle, 5 centimeters and 12 centimeters. If set 2 is the set of zeros of the function fx equal x power 2 minus 2ax plus a power 2, then a equals, we put x equals 2 in the function, we get 4 minus 4a plus a power 2 equals 0. We factorize this expression, we get a equals 2. Number 2, the set of zeros of the function fx equals x power 2 minus 25. We put x power 2 minus 25 equals 0. So we have x power 2 equals 25. We take the root of the two other sides, we get set 5 comma negative 5. The last example, the set of zeros of the function fx equal x bracket x power 2 minus 2x plus 1. We can factorize this expression. X bracket x minus 1 bracket x minus 1 equals 0. So we have the set of zeros is set 0 comma 1. The domain of the function nx equals 2x minus 1 over x power 2 plus 1. We put x power 2 plus 1 equals 0. So we have no real values of x to make denominator equal 0. So our domain is R. The second, the domain of the algebraic fraction x minus 5 over 3 equals the domain of the algebraic fraction. So the domain of the fractional function x minus 5 over 3 is R. And x over x power 2 plus 1, its domain already R. Yes. If fx equal x over x minus 2, then f2 not exist. It has no value, so undefined. If the domain of the function px equal 3x over x power 2 minus 4x plus L is R except 2, then find the value of L. We put x power 2 minus 4x plus L equals 0 and replace the value of x with 2. We get 4 minus 8 plus L equals 0. Finally, L equals 4. If the domain of the function f, where fx equals x plus b over x plus a is R except set negative 2, and f0 equal 3. Find the value of each of a and b. Let us solve this problem. So, we have the domain R except negative 2. We have x plus a equals 0. And replacing the value of x with negative 2, negative 2 plus a equals 0. So we get a equals 2. We have f0 equals 3. We put x equals 0 and we put a equals 2. We get 0 plus b over 0 plus 2 equals 3. We get b equals 6. Number 2. If the set of zeros of the function fx equal ax power 2 minus 6x plus 8 over bx minus 4 is set 4, and its domain is R except set 2, then find a comma b. First, the value of x equals 4. We put x equals 4 up. We have ax power 2 minus 6x plus 8 equals 0. So we have 16a minus 24 plus 8 equals 0. From this equation, we get a equals 1. We have the domain R except 2. We put x equals 2 in the denominator. We get bx minus 4 equals 0. 2b minus 4 equals 0. So b equals 2. 2. Thank you for listening.